All right, hello once again, Jeff Scott of Rankin Technical College. As part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD1100 C# Programming Fundamentals course, I have been going through a series of video presentations based on the book used for that class. As you can see here, it's Muroc C# 2015. I have gone through all of Section 1 and all of Section 2, which puts me in Section 3, and I'm in the middle of Chapter 12, How to Create and Use Classes. Now, in this case, notice we've got things in here that are static. All right? When something is static, you do not have to create an instance of a class in order to be able to use something static. All right? So the class itself can call the method or use the piece of data. Now, I'm not sure what exactly what the author is trying to show here, but usually the example I give of static is, imagine that years ago I taught a Java class, Java programming class, and the book that we had, which was a pretty good book, I don't remember it, except I remember it had a mouse on the cover, all right, but it worked with a balloon. Sounds silly, but what happened was you had a screen, and on that screen, you would have 3 buttons. The first button said Create Balloon. So every time you clicked the button, it would put a little dot on the screen that would represent the balloon. Then there was another button that said Make Balloon Bigger. And every time you click it, the balloon got bigger. And another one called Make Balloon Smaller. Every time you clicked it, it got smaller. Probably makes sense to you. All right. But every time we created and clicked the button that said Make New Balloon, we had what was called a balloon counter. So if I made 6 balloons, I'd want that balloon counter to be equal to 6. So that counter was static. It didn't belong to any object. It was shared by all of the objects. And I could at any time ask for balloon.count, and it would show me how many balloons I had made. That's my way of describing static. Maybe it's not as good as the author's. I don't know. But data can be static. Methods can be static. But with either one, when you work with static data or static methods, you do not need to instantiate an object of the class to call or use them. The class itself can use them. All right? Now, here they're talking about the tag property settings. So this code, txt code, has a thing of code, txt description, txt price is price. Why does that matter? You may or may not remember from an earlier chapter, but by setting this tag property, it allows you to easily grab data and to be able to use it between different classes. Now, we've already looked at this product class. We've looked at the properties, we've looked at the method. We've looked at the 2 constructors. Now here's another class. It's called product DB. Probably you're saving the product instances to a database. We've got a get products, which will return a list of all the products that are in the file or database or whatever, and a save products. All right. Notice they're both static methods. One returns or gets a list of products. One writes a list of products, all right, to a file. And as the author says here, you don't need to know how the product DB class works. You just need to know what methods it has and how to call them so you can use them in your program. Here we've got another class, validator, which has got a title, which has got a static string, and it's got 4 static methods. Is present, meaning is there a title in there? Is in 32, which means did that text box have an integer in it? Is decimal, meaning did that text box have a decimal in it? And is within range. So if it was a numeric value in a text box and you gave it a range, think about why you'd maybe use something like that. Maybe you're representing A, B, C, D, and F as 0, 1, 2, or 1, 2, or what? 4, 3, 2, 1, and 0. All right? So here's a product maintenance form. Now it says here this is a partial class, which means that it can be combined, or is typically going to be combined, with code in another file. Here's the form. It right here, :form, means that this form right here, this class, form or FRM product main, inherits from form. Here is the constructor. It's calling initialize component. Here is going to be a list of products which currently holds nothing. All right. When we call load, it's going to go out and find the file that contains our products and fill up that list box with those products. Right there. When we want to add a product, all right, we're going to fill out, and if it turns out that that product, again, is going to have in it what? A code, a description, and a price. We fill those out, and we add it to the list box. We can also delete current products. Before we delete a product, we ask, are you sure you want to delete this? If you say yes, it's gone, and exit will close the program. So what do we have here? We've got our get new product, which will allow us to grab an individual product, and our save, which will validate the data. All right. And if it's okay, it will save it. Notice code, description, and price, and then it'll close. So this is going to return, and it's going to say, is what was put in here valid? Is what was put in here valid? In fact, these are just going to say, are they present? Is there a code, and is there a description? Is there a price, and is that price a decimal? Pretty simple stuff, really, when you start to look at it. But what we're doing is we are taking this application and breaking it down into a series of classes. Now, a couple more things. Auto-implemented properties. When we were doing our properties, we were always doing this. Where are you? Get, set. And that's totally fine. But you'll notice we're not doing any validation. Just saying return it, or whatever we passed in, set it. Well, if we want to, rather than going through all that work, we can just say get set. Here is a get, and we are setting the initial value of the code to CS15. Again, notice get, and it's on the right-hand side of an equal sign. We're copying it to a local variable. Set, it's on the left-hand side of an equal sign, and we're copying the value of something into that property. We've already talked about read-only properties. Here's the same property using an expression body. All right, so rather than just having a get like this, now we're actually putting in a lambda expression. Here we're returning something, not all that different from what we just looked at. Or doing it with a lambda. And they've got, again, several examples of this. All right. Using live code analysis to generate a class. So what they're saying here is when you're doing this, you're going to get an error because that doesn't exist. So when you click over here on the light bulb, it gives you possibilities to fix this. If you choose Generate Product in Code Stubs in New File, it'll create something like this for you, where it will make the class and put virtually nothing in it. Now, when you do this with a method, and the method doesn't exist and it creates it, it typically will create something like this. Here's the method. It expects a string, and notice throw new not implemented exception because we haven't written any code for it yet. All right. Now they talk here about this code lens, and it says Community Edition doesn't have the code lens feature that lets you display references, and I believe that's still true. And I'm using Community, so I'm not going to do anything with it. Class diagram. Typically, if I come in here, come on. Well, not letting me get out of here. There we go. If I go back to my program, and I right mouse click on product here, well, I want to make sure I'm telling it to you correctly. So I'm going to open my book up. See if I can find this in my book. So it says that a class diagram, let's jump back to here. This is a class diagram, is a visual representation of the methods, properties, fields, and events for one or more classes. To create this, right-click on a project in the Solution Explorer. So that's what I screwed up with. So we want to right-click on our project. All right. And select the View Class Diagram command. Is that in here? Or right-click on a class and select the View Class command. So that's what I thought I was doing. Right-click on the class and choose the View Class command. I don't see it in here. I have no idea if there's a class diagram in here. There's classes. Now I would think it would be in the same area, but I don't see it. So I will have to check on that, I guess, because I don't see it in here. And rather than wasting my time or wasting your time, I'm just going to go on. All right, there are about 10 slides left, and I'm at 14 minutes. There's a peak, which means you can be in one class and you can check out the code that's in another class. All right? And next they talk about structures. I was always taught that a structure basically is like a record. All right? So you can say public structure name. They're not, for lack of better words, they're not as strong as classes. All right? But when you look at this, it sure looks a heck of a lot like the class that we created before, except rather than saying public class product, we're saying public struct product. It's got the same stuff in there. And we create the stuff in there pretty much the same way. See that? So they both can be used. All right. So let's see. I'm going to go back to the book one more time because I am just about finished here. And see if the author talks about when to use one as opposed to the other. A structure is similar to a class, but it defines a value type rather than a reference type. Although structures require less memory, so they instantiate faster than classes, it's generally considered a good programming practice to use them only for objects with a small amount of data, otherwise use classes. Don't know if that helped at all. All right, so we're done. I will come back in a bit, and when I do, I am going to try to figure out why that program wasn't working, and I'm going to also open and go into Chapter 13, which is on how to work with indexers, delegates, events, and operators. So I will be back with that shortly.